for the India also, they are running very in a very good speed. So means you can give this task sorry to your BTech or your MTech students, so that they can write a report also on or even they can publish their papers also. So let me start with this. So we will discuss some energy promotion policies of the government. It may be broadly, I consider only two policies. One is of the Rajasthan and one is from the India. And present status electricity generation, at least we should know that, okay, this is our demand of energy, of electricity in India, or according to that we can think that, okay, whatever the generation is going on, that is as required or not. Then we will discuss the renewable energy source like solar and the wind broadly. I will also show you some 2 or 3 videos which will just a idea of renewable energy, that how the renewable energy or distributed generation is basically going to take place in India, like in Rajasthan, solar power station parks. I will show you one video regarding that, and 1 or 2 videos regarding one wind, and one is of policy, that is Griha. Griha is a policy. You can say it is like a NBA. In NBA, a institute is rated for a different rating. They are getting some accreditation for 2 years or 3 years or 5 years. So based on that, Griha is also there. So 2 or 3 yojnas I will discuss, and definitely you will appreciate this yojna, and maybe you can further implement it. So types of modules, some manufacturer, some what is the need of solar photovoltaic. So this is the first yojna, Kusum yojna, that I will discuss. Then wind, some part we will discuss regarding the wind energy. Then in any of the case, means of solar or wind, you can have a single stage and the double stage system. So here only a brief idea I will give for the single stage and double stage photovoltaic system. Then a brief 2 or 3 slide for the results, so that at least okay, we can compare that, okay, single stage or double stage, what is difference and which is better. Okay, so problem with the conventional source, I think that you all belongs to very reputed institutes, and definitely I think this slide is very no any significance, but at least I'm again briefing it, because shortage of the fossil fuel, coal, oil and gas, these are means day by day we are listening that the prices are international prices are hiking, and then due to that the oil prices are increasing. Similarly, coal, the transportation in the coal, the handling, the mines and of the coal. So these are very far away from the load center or from the generation sites. So their handling, their maintenance, their transportation is a very typical task, and definitely there is a limit. There is a limit of digging. Means it is not like that for up to the thousands of years we can dig the coal from the mines and we can generate the electricity. Or you can say, sir, instead of the coal, we will shift our generation to the nuclear. It is not like that. Means it is not like that, because I think in the Japan, you already know, I think in some 2 or 3 years ago, there was a tragedy in Japan also. There Fukushima, I think nuclear power plant was there. So means we cannot think that every city or every state having 4 or 5 nuclear power stations. We cannot think like this, because always there is a danger, and we cannot then you can say, okay sir, we will shift to the hydro. So I think that you all are related, all are belongs to different states of the India. So you better know that what is the dams situation in India, what is the water situation in India. Means in some states like Rajasthan, though always there is a scarcity of the water.
Excuse me, sir.
Yes.
Sorry to interrupt you, sir. Slides are not moving actually. Only first slide is showing.
I know
Okay,
that.
Sir.
I am only discussing first point.
Okay, sir.
I'm only discussing first point.
Okay, sir.
Okay. So Yeah, where was it? Okay, there is always scarcity of the water, like the state like in Rajasthan. Okay, I'm not discussing with other state like Chhattisgarh or okay Bihar. Always there is a flood type situation, so that is also not beneficial for a dam, and no water is also not beneficial for a dam. Means we have to think, that okay, by the time we have to shift our demand. So pollution is again a very massive problem. Then it is harmful to the wildlife and the surrounding environment. Definitely, when you are preparing some nuclear power station or some hydro power station, definitely you have to shift the your wildlife all the surrounding environment is become. I think if you have visited in your life to I think Uttarakhand or Himachal. So in Uttarakhand, there are so many hydropower stations. So if you will see, so you will feel a very sorrow in your heart by seeing those poor, pathetic condition nearby to that dam. Means all the trees that are cut down, all the mountains are now become very means without any tree, you can think about what is the beauty of the Uttarakhand. So like this, you will not find in a very good environment. So that's why I'm saying high cost, difficult to supply, high demand also. That means we cannot rely always on this system. Long transmission line always is a problem. Then not even or no means in case of like the if you have the load center, so it is not always possible that the your generation it will be always near to the load center. So if the generation is approximately 500 or 1000 kilometers away, or because now you know that India is divided into 5 zones, and all zones are interconnected. So the long transmission lines is their handling is always a major problem. So then location specific NCS is commercially viable, also not. Then efficiency level and inconsistent and unreliable supply. Then what is the solution? There are so many drawbacks which we discuss. So then solution definitely is that we have to divert our energy demand, and we have to think on the renewable energy sources which are widely. I should not say that only one state, I should say nation, I should say around the globe, people are thinking, researchers are working on the renewable energy and renewable energy control algorithm, and their different product, different yojana are coming into the market by the government, not only the state but the center. Okay, so this is the present status as of the electricity generation. This you can check these data, because these data are normally updated by the in a month time, in a quarter also. So you can check with this data from MNRE, Ministry of New and Renewable Energies, and so you can check this data. However, just I'm briefing it. The total energy generation it is approximately 382.73 gigawatt. And out of that 382 or 380, you can think gigawatt, approximately 203 is based on the coal. So if you can think that still, and then approximately 6.7 from nuclear, and then 27 approximately gigawatt from the gas. Means like NTPC power stations are normally based on the gas power plants, naphtha gas they are basically using, and some are the approximately half gigawatt from the diesel. It means that it means if you will calculate this, so it is approximately 250 gigawatt. So means out of the 380, 250 you are generating from the old conventional techniques. So it means that you have to think in a another way, that because always there will be a problem of the coal digging, and these natural sources definitely these conventional sources will be definitely means by the time they will be vanished from, even not from the state but center, even from the earth. Then what will be the solution? We have to think. So you can see here solar power, you can see here wind power and smart hydro. So you can think that okay, we have to transfer this area of the coal generation to the solar and the wind. Means share of the renewables you have to basically increase, and so that we can also increase the average electricity consumption by per capita, you can also increase. And also you can reduce the transmission and the distribution losses, because if you will know, if you will do not use the long transmission lines, then automatically it will, when your generation is near to the load center by using the solar or the wind, then automatically the transmission and the distribution losses, which is a significant losses in any system, so that can be reduced. Overall, the benefit will go to the customer. Overall, the benefit will go to the customer. Yeah. So this is the data again. This is the data from Central Electricity Authority. So you can right now you can check latest data also. If we are again, you can if you will combine the central sector, state sector, and the power sector, so it is 382,730 megawatt. It means it is approximately same 3.82 382.73 approximately gigawatt. So this is the energy basically installed capacity. Out of that, you can see 25% share from central sector, 27 share is of state, and then 47 is of the private sector. And then again, it can be bifurcated into coal, lignite, gas, and diesel. However, your RES, your renewable energy is approximately 95 gigawatt out of this 382. Then, so broadly, see, in the renewable energy source, there are different categories you can divide. Broadly, you can divide it into solar and the wind. So due to the issue, as we discussed, the emphasis has increased towards the environmentally clean and cheap source of energy, that is the renewable energy. So such as you can say with photovoltaic system, which leads to the better energy efficiency and reduction in the pollution. However, you can ask me, sir, definitely your answer is correct, but what you think about the pollution? Don't you think that these semiconductor devices, when they will no use, means when they will be out of their life, means after the 25 year or 30 years, when any semiconductor panel or semiconductor that devices will not work, then what about this panel? Don't you think that this will pollute the environment? So see, always any technology having the advantage and the disadvantage. So right now the generation from the renewable energy source is a prime task, and you will surprise that the life of these panels is approximately now 25 years to 30 years. So it means that they are giving, and even researchers, material science researchers are basically doing the research in this area, that how they can increase the efficiency and how they can increase the life of these particular panels. So so advantage and so disadvantage are always associated with the disadvantage. Secondly, the dependency on the conventional transmission network can be reduced by interconnecting these renewable energy hubs, so near to the load center. As I told you, that if these RES systems will be near to the load center, definitely the losses and in the transmission and the distribution side can be reduced at a very great extent. And also, if suppose let load center is getting the required amount of energy, and if some excess amount of energy is there, so that can be feeded to the local distribution network. So based on that, there are feed-in tariff, there are net metering or gross metering, are different types of metering techniques are there. So by that you can always calculate, okay, this much of energy is usable and this much of energy is basically again feeded to the grid, so that it can be used further to another customer or another user. Photovoltaic energy has great potential to supply energy with aforesaid advantage, and it is useful and primary choice for a wide range of this. So capability to direct convert to the electrical energy using the solar cell, basically, that is photovoltaic semiconductor devices, PNN junction are there. So basically that and then when they are aggregated in types of a plate, so then it becomes a solar plate. So approximately 16 volt to the 20 volt basically panel of the 250 watt to the 300 watt panel can give you, and with a short circuit current is approximately 8 to 10 ampere, or normal current depends upon the normal current depends. This is short circuit current, but this is not the load current. Load current will be depend definitely when your load will be connected, and the same is applicable for the wind also. So different photovoltaic panels are there. So you can go with the mono, poly, and thin films. However, in case of thin films, I think you all are aware that nowadays your buildings are building in the front side, the side, both side and the back side, rear side also is making the glass. So that the sunlight can be directly enter into that vicinity. It may be a institute, it may be a mall. I think you have seen the mall also. So normally you will see that now there are no walls, or the wall is replaced by the glass. So this thin films type of photovoltaic panel can be used there, and they can generate the electricity. So now you can think that for making a smart city is not making the malls and airports or the transportation system. No, if you have to change the conventional methods of the generations also. Means it thorough change will, if when the thorough change, a complete change will be there, then only we can think about, okay, it is a smart city. It's not like that, okay, controlling the active power and the reactive power is like the facts or like the smart city. So to make this cell for monocrystalline panel, silicon is the formed into bars and cut into the wafer. So you can see here, this is the detailed diagram. So there are into bars and then cut in the wafer. But here in the case of polycrystalline, fragments of silicons are melted. Means many fragments, many crystals of the silicons are melted together so that it can form the wafer. Normally both having their advantage and the disadvantage. Like, okay, it is not considered here, but normally the cost of the mono is higher, efficiency is higher. However, the cost of the poly is less as compared to mono. Normally the mono is, however, you can, I mean, efficiency is approximately same, but the cost is lower in case of the moly due to the many fragments are there. So it is the solar PV panels manufacturing in India, like Vikram Solar, Tata Solar, Sukoem, and Indo Solar, Wadi Solar. These are the some manufacturer companies which are considered as a solar manufacturers in India. These companies are selling multi-crystalline modules, poly thin films also, starting from even less than 10 watt. I think approximately 5 watt also in the market nowadays, and not the 260. It is approximately 300 to 330. However, we all are exporting these solar panel from the other countries. We are very limited.
Sir, excuse me, sir. Sorry to interrupt you, but we cannot see the slides moving. The slides are not moving forward.
Pardon, ma'am. Sir already have cleared. They are telling about the introduction about the topic. You joined late. Sir already informed this thing.
Okay, thank you. Sorry, sir. Yeah, thank you. Please.
No problem. Basically, see, my aim is not to only read all the 40 slides. My aim is only, if I will read only one slide, so at least that one slide should be understood by the participant. This is my aim. Okay, now see, all are having different way of teaching. So so don't be panic. I will go through all the slide, but I have to give time to each slide so that at least whatever is written on that slide, that can be understandable. Okay, so don't confuse. Okay, so these panels are so these panels have, yeah. So I was talking about that. The wattage rating is maybe 260 earlier, but now it is coming by 300 or 330. Reliance is coming with a new proposal. I think in a couple of month or couple of years, may not more than, I think, 1 year or 2 year, they are planning to put a manufacturer hub of these panels in India. So once, because approximately it is 25 rupees per watt approximately. So once a local manufacturer will be there, so definitely the price of the per watt will be reduced. And also this, as I discussed in the previous slide, so 25 years, so approximately it is now increasing by 30. There always there is a, see, you cannot say that, sir, some in a natural climate changing or some hazardous situation. See, that is not covered normally. Any product is not covered for that type of climate change or for any type of this type of problems. So okay, there are some international solar manufacturer also, like, okay, so yeah. So this is the situation. I see there are many states in India, like Tamil Nadu, like Gujarat. Gujarat is also a dominant. However, the Gujarat is very well known nowadays for the wind energy generation system. So due to the coastal area, like Tamil Nadu also, even in Tamil Nadu, the solar and the wind both are having on boom. So this slide basically just to give you idea that what is a solar park. So because I think many of you have heard this term in literature also. So there is a video which will give you the idea about one of the very prominent or very good solar parks in Rajasthan. The name of the village, that is the village or tehsil, is Badla, which is approximately 60 to 50 kilometers from the Jodhpur. This is one district in the Rajasthan. The participant who are not belongs to this state. So this is this is like Tamil Nadu or other state. So, and this city, Jodhpur is a very well-known city. I think you all know, and Badla is the one small town in that. So there basically government is planning to put the solar park. All these solar parks are grid connected. This is very important. See, there are two technology. I will discuss two technology. One is the off-grid system, and another one is the on-grid system, means grid-tied system. You can like a solar rooftop system. So a solar rooftop system can be run in both of the mode. That it can be run in isolated mode, means you can generate your own electricity, and you can store your electricity in the form of battery, and then you can use it. However, the second case is that whatever the energy you are generating, you just use it, and whatever the rest energy you can feed into the grid. So that is an on-grid system. So this is a just installed capacity, and you can see here 680 watt, 1000 watt. These are the commissioning and different phases are there. So this is one of the solar park. Let me see this video, so it will definitely give you the idea. Okay, Ashish.
Yes, sir.
Once this video I'm playing, so kindly tell me that okay, voice is coming or not. Okay.
Sure.
This is India.
Yes,
one
sir.
of the fastest
Voice
growing
is coming.
countries in the world, and also the second largest energy consumer in Asia. With growing need for energy security, it is time to switch to an era of renewable energy generation. In 2015, Prime Minister Shri Narendra Modi announced India's goal of producing 175 gigawatts of renewable energy by 2022. This goal includes 100 gigawatts of solar power. Rajasthan, one of the most solar developed states of India, has easy access to two components critical to the production of solar power: high levels of solar irradiation and vast stretches of flat and undeveloped land. In order to effectively realize the massive potential of these resources, Chief Minister Srimati Vasundhara Raje issued the path-breaking solar energy policy in less than a year after assuming office. Today, Rajasthan is the second highest solar energy producing state in India, with total installed capacity of more than 2,000 megawatts. Badla Solar Park, located near Jodhpur, is a mega solar park project of Rajasthan. The park is being developed in 4 phases, and the first 2 phases have already been commissioned. Of these 4 phases, Phase 2, 3, and 4 have been approved by the Ministry of New and Renewable Energy under the Scheme for Development of Solar Parks and Ultra Mega Solar Power Projects. Rajasthan Vidyut Prasaran Nigam and Power Grid Corporation of India are constructing grid substations for evacuation of power from this park. The first 2 phases have been developed by the Rajasthan Solar Park Development Company, a subsidiary of Rajasthan Renewable Energy Corporation. In the first phase, 5 projects of 60 megawatts have already been commissioned. The phase has a total capacity of 75 megawatts. The National Thermal Power Corporation has set up a project of 200
video cannot be seen, sir.
in the second
Yes.
phase.
Video cannot be seen, only sound is coming, sir.
Video is not even.
Yes, sir.
Development activities such as
By
construction of
every
roads,
participant
water
are not
supply
able to see the
systems,
video?
cooling stations and transmission lines have been completed with a capacity of 1000 megawatts.
Any
Phase
participant
3
is able to
is
see the
being
video also? Any participant is able to see the video also?
No, sir. Only
No.
audio coming.
No, sir. No, sir. Only audio.
Okay, then no problem. Okay, I missed it. Basically, this was the video for the solar park. Okay, maybe big, but why it is not coming, I don't know. Okay, let me move further. Okay, so this is the that's what the video regarding the solar park. So okay, there was 2 or 3 videos are also there, but maybe I don't know why the problem is coming. Okay. We will again see later. So this is the basic scheme led for the solar energy conversion. We will first finish it, and then we will go to more toward some policies also. So this is the basic scheme for the renewable energy source. So here you can see it may be a solar, it may be wind also, and the concept is same. That the energy which we are generating from this RES, and this is the load, so we have to give this energy to this load. But the thing is that this energy is uncontrolled because there are climate change and solar irradiation or wind speed may be changed. I am only considered these 2. So due to that, there will be a power electronic converters. So this is the term, I think, which is very well known by the electrical engineers or the electronics engineers also. Power electronics converters are basically those converters which control the one form of energy to the another form of energy. Or you can say this is working as a power electronic modulator also. So this is used for this, and this closed loop system is basically used so that the energy which we are feeding to the load, so that is as per the requirement, and if it is excess, so that excess amount of energy can be stored in the form of a battery, or that energy can be again feed to the grid also. So these are the some trackers. Yeah, this is very important. So these are the some trackers. So I think many of you have seen these trackers in your institutes or the hostel sites also. So these are the built electric power plants or mirrors or lens to concentrate more sun radiation on solar panel to get more output power. So these are the tracking the sun and it's change the position. If any participant is from mechanical, so they can work on the tracking. They can work on the tracking of this solar mirrors, because as the radiation of the solar is basically changing throughout the daytime, so the direction of this energy tracker has to be changed. So they can work on this. This may be a research area for them. Okay. So yeah, this is again one of the another example of solar energy conversion, that is thermal. I think you already have seen again at your hostels, in your hostels, or if you are at the rooftop of many houses. These sun radiation is in the visible wavelength goes through a transparent layer. It may be I think from of a glass or plastic, then absorbed in a black layer and heated it up. So this black sheet absorbs the radiates and absorb the energy in infrared wavelength. So what we feel as a heat towards the glass layer. So this glass, however, is not transparent to infrared. So here this heat is trapped there, and it can be delivered to the water or air, so that can be used further for the drinking or for the cooking purpose, or for making the room as a heat. Nowadays, I think this technology is also using in the locomotive, in the trains also. This is the scheme for the off grid. Okay, it can be on grid or off grid, and on grid also, both things. But this is the general scheme. Here you can see in that slide there was I think the battery was not present there. So you can see this is only for the solar. So you can generate the energy. This is the DC output. Okay, then some fuses for the protection we are using, then some inverter. This is the power electronics converter. So the participant who belongs to the electrical engineering, I think many of you are doing the research that okay, how we can increase the DC input, how we can increase the efficiency of this inverter, what are the different PWM technology for this inverter. So many of you are working on this issue also. And then this is the consumable, means consumption by the load, and you can also have the remote control panel. So here IoT works. Here your IoT works, means you at the remote site also you can make a software, and you can see okay, this much of the power consumption by your load, and then this much of surplus power is there. So you can feed this power to the battery, or you can feed this power to the grid also, again back to the grid also. These are the rooftop solar photovoltaic system. I think many of you are maybe using at your house, or even at your institute level. Many of us we are using. This is the one of the very important project or the yojana, that is the Kusum Yojana, and this is related for the agriculture side basically. I think many of you have heard that in villages still electricity is a major problem, and for crop farmers has to wake up in the early morning, and then they have to give the water to their crops, because normally in the villages a three-phase connection, three-phase lights are coming approximately in 3 o'clock to 6 o'clock. So at that time it is a problem, means in the winter it is a problem. So this Yojana, which is Kusum Yojana, can solve their problem. This is not related to the Rajasthan. This is the Indian government project. So the many extent it can solve the problem. What is this scheme? In this scheme, you can see in the figure also. This is a solar panel, and this is your submersible bore or submersible pump. And instead of giving the electricity from the normal grid, we are giving this electricity to this bore from the solar panel. So means it now farmers do not need to walk up, or do not rely on the grid, do not think about the time also. As per their convenient, they can give the water to their crop as per the requirement. There is a float switch also. Automatically when this float switch will touch to this level, automatically your outlet pipe will be stop your submersible pump. Means like this you can save the water also. You can shift your generation from normal or the conventional scheme to the solar scheme. So approximately 20 million grid-connected agriculture water pumps are installed in the country, which consumes more than 70% of total annually. These are the agriculture water pumps installed. So and normally they are generating by the normally by the diesel, or by the your normal conventional electricity. So if they can be replaced, by using the solar. So there are two benefits. One benefit, you can increase the productivity of the farmer, and also you can also in a position to sell the surplus power to the discom, and it is a source of the income to the farmer. So it is a very good scheme. You can give some small project to your BTech student or to your MTech student to make a report on this, and you can even publish some small papers also on this scheme. Yes, so this is the implemented project in one of the village in Rajasthan near to Jaipur. So you can see here there is a pump is there, and this pump is fitted by this solar panel. So approximately now 300, so approximately 1 to 1.5 kilowatt means panel is there. So you can generate electricity even in morning time, even in daytime normally, and even in night. I think there is no need to give the water to the crop. This is the another projects, because I am talking about different projects. So you can see this is for the street lights. I think many of you have seen this in your campus and in different parks. Under this project, this is Atal Jyoti Yojana. Earlier that was Kusum Yojana. This is Atal Jyoti Yojana. Just kindly hold. हल- नहीं हो रही है, देखिए। हाँ, हेलो। नहीं, ये स्लाइड आ रही है। ठीक। Okay, slides is visible. This slide is visible.
Yes, sir. Now
Yes,
it
sir.
is visible.
Yes, sir. Yes, sir. Yes, sir.
Okay, and now this is visible.
Yes, sir.
Okay, so I was talking about, so this is clear, na? Kusum Yojana is clear by all the participants. So now we discuss with the another Yojana, that is the Atal Jyoti Yojana. So it is planned in the year 2016 to replace the existing fluorescent based lamp with this solar based street lights. So approximately, I think in many states, not only the Rajasthan or Gujarat or any other, many states, they have replaced these conventional lights, fluorescent lamps with this scheme. So there are different phases. I am not reading this figure because see, this figure are normally day by day changing. It depends because every scheme has to be implemented in number of phases. So that's why this may be increased day by day. Okay, so let the another we can think about discuss let some idea for the wind. So this is the a basic diagram for the horizontal axis wind turbine. So you can see here, this is the rotor, these are the some plates, and whatever the speed of the wind is there, based on that the rotation will be take place in this wind, and this is attached with the shaft, and a gearbox is there. This gearbox is basically maintained so that to increase the speed, and this is the generator which is connected to the grid later, and then we can also have the controller also, and for making the wind flow, that anemometer is also there. So this is a tower, everything. I think this is especially the mechanical people are very well known of this structure of this. However, as far as electrical or other branches are concerned, we are normally thinking about, okay, the generation should be from generation should take place. Okay, now I am running this video.
How does a wind turbine work?
Now, Ashish, now this video is coming.
You've probably seen a wind farm.
Yes, sir. Yes, sir. It is visible.
But do you know how
Video
wind
is coming
force
now?
is converted into electric?
Yes, sir. Yes, sir.
Okay.
We are going to show you how a wind turbine works. Each wind turbine has a wind vane at the top that indicates the wind direction. This allows the turbine to rotate on the tower and face the wind. The blades also rotate on their axis for maximum resistance. Wind force, that is, the kinetic energy contained in moving air currents, spins the blades. These are designed to fully capture its energy. They can be as long as 60 meters each and are made of very light and resistant materials for ease of movement.
This is approximately
This is
60
why they
meters.
can produce energy even with very light winds, starting from about 11 kilometers per hour. With very strong winds, above 90 kilometers per hour, the blades are placed in the feathered position and the turbine stops spinning for safety reasons. The blades are attached to the wind turbine through the hub, which is coupled to the low-speed shaft. The low-speed shaft is given this name because it spins at the same speed of the blades, between 7 and 12 revolutions per minute. To produce electricity, it is necessary to increase the turning speed of the low-speed shaft. That is the mission of the gearbox, which raises the speed over 100 times and transfers it to the high-speed shaft. The high-speed shaft, that rotates at up to 1500 revolutions per minute, is connected to a generator. The generator converts the kinetic energy into electricity, a source of energy that is easier to transport and use. The electricity produced in the generator as direct current is conducted through the interior of the tower to the base. There, a converter transforms it into alternating current, which is the most commonly used kind, and a transformer raises the voltage for transport inside the wind farm. From each turbine, alternating current is sent to the substation through underground cables. Here, the voltage is increased again to feed it into the power grid and transported to end consumers. This is how we use the wind to light cities, feed industries, schools, or hospitals, or operate our household appliances in a clean and sustainable way.
Okay, so this video was related to the wind turbine working. So let we consider again come to the wind energy conversion system. So again, this is the brief regarding the, so as we discussed for the solar also. So wind is coming, and you can go with the DFIG, or you can go with the W-fed induction generator, or you can go with the permanent magnet synchronous generator. And this is the converter part. Because directly we cannot use this power, so we have to increase the levels also. And then so AC to DC and DC to AC converters are there. Then some for the filtering purpose, filters are there, and by using the coupling transformer we can increase the voltage level, and then we can feed the grid. I think as you have seen in the video, this is the same thing which I'm not discussing with this. Same thing for overall efficiency. Okay, so Government of India has established a special nodal agency. So this is the name of the agency, Ministry of New and Renewable Energy, MNRE. See, in 2006 to deal with the all matter related to the renewable energy policies or renewable energy hostilities. MNRE, in conjunction with GOI, Government of India, has launched Jawaharlal Nehru National Solar Mission, JNNSM, on 10 to accomplish the target of 175. However, now as you heard about that, our now Government of India mission is approximately 275, and now they are increasing to 375 gigawatt by 2020 and then 2024. Out of them, approximately 175 already, approximately 100 to 125 gigawatt already we have achieved. So by installing a total of 34 solar parks with a gross capacity of 20 gigawatt in 21 different states. However, this already goal we have achieved. In addition, Indian government has launched various conductive initiatives, like they have issued the renewable purchase obligations. Means in any situation you have to purchase this much of energy from the other state or from the central, from the government. So that is basically RPO. In any case of depreciation also, there is a accident depreciation also they have to face. They have to feed in tariff. What is the gross metering? What is the net metering? What is this? And renewable energy certificate they have to also, means they are conducting some initiative, so that at least there should be some regulation on these, always on these schemes. So this I was discussed earlier. So there are two types of policies. One policy is basically they are preparing for the grid interactive renewable energy policies, and another one is for the off-grid. See, it hardly doesn't matter in the policy, but normally we have to classify at least at some extent or at least some level. That's why it is. Both policies can be defined, then can be defined for urban area, for the rural area, like this. This is one of the very important scheme, Deen Dayal Upadhyaya Gram Jyoti Yojana, that we will discuss in the next slide. And some schemes for the special area demonstration program or for the rural areas. The main objective behind launching the grid interactive solar scheme policies are to increase the share of renewable into the traditional electric power system. So this is the basic theme. So that's why the national rural electrification policies, so there are always an amendment in 2006 to 2020 or to 21 also. However, the main theme is to electrify the rural areas. Or see, electrification in the rural is still a challenging task. That's why we are discussing something related to the rural. Then Indian government has launched the Deen Dayal Upadhyaya Gram Jyoti Yojana for electrification of rural hamlets on far-flung island like the Andaman Nicobar. Like these some area, I think maybe in the Daman also, maybe far-flung island also there. So for that, this type of yojana is there for the rural hamlets. So this Deen Dayal Upadhyaya Gram Jyoti Yojana is a Government of India scheme which is designed to provide continuous electric supply to the rural India. The government plan to invest approximately 756 billion for this rural electrification under this scheme. This scheme is replaced by Rajiv Gandhi Gramin Vidyutikaran Yojana. Scheme is always changing and the budget is always changing. Slide is visible, Ashish?
Sir,
Slide is visible.
22 number slides, wind energy conversion. Wind energy conversion slide is visible, and I think not moving again.
I don't know why it is going. I don't know.
Now it's.
So it means that I should now I will not move in the whole screen. So this is visible now.
Yes, sir. Yes, sir. Now it is
So
visible.
so this
24th number. Okay.
okay. So this policies I basically discussed here. So the different policies I discussed. Then I'm discussing about the interactive and grid objective. So in grid interactive, I was discussing with the Deen Dayal Upadhyay Gram Jyoti Yojana. So this Deen Dayal Gram Jyoti Yojana is a government of India scheme which is designed to provide continuous supply to the rural India. So this government plans to invest approximately 750 billions for the electrification. The main purpose of this Yojana is to provide the access to electricity for all household and with a cheaper cost by the year 24 or maybe later than that. And also everybody can get the electricity. Under this scheme, Central Finance Assistant, this is a very important term, Central Finance Assistant CFA, up to 75, they will give you, they will give the state or to the mentor also. And this percentage is increased 90% for a special category state like Jammu and Kashmir, Sikkim, Uttarakhand or Himachal Pradesh. So this is about the scheme. Means approximately you can see here the approximately I think 586 approximately 586 and 567 villages approximately electrified across the country. This is some policies for the off-grid. This is we cannot make some very large difference, but policies are making by the policy makers, which are the rulers basically in India. So hardly there are the very small differences there. So remote village electrification program and then special area demonstration program. So like a special area demonstration program means this scheme of MNRE has been introduced with an objective of demonstrating the various key benefit of using new and renewable energy source at place of national and important national, like this seminar. Whatever the seminar is going on right now, so this come under this special area demonstration project program. Means we are promoting different schemes. So if this scheme, if this type of seminar, if this type of courses are normally run by any agency at some remote area or rural helmet, or so it means you are developing the concept, you are promoting that concept, you are enriching that particular persons by that concept, and you are increasing the knowledge. So it has been recommended in this way that the demonstration of this scheme should be done by showing the working models. Working model means like LED model or cut model powered by renewable sources. Now this is going on. This slide is visible. 29 slide.
Yes, sir. Now it is.
So again, the renewable energy source for rural areas. So in this project is designed to fulfill the objective of developing and demonstration of a commercially viable model for electrification in this rural and through the non-conventional source. And very important, now we will discuss another policy, very important. With the assist of green rating for integrated habitat assessment. This is the GRIHA. So MNRE has selected a program to develop energy efficient building. I think nowadays you are knowing the concept of 3-star, 4-star, 5-star rated appliances. Means like your LED TV or your refrigerator, 3-star rated, 2-star rated, 1-star or 5-star. What is this? Basically based on the power consumption, you are dividing. You are based on the power consumption, based on the losses. You are dividing your basically device into different ratings. So, okay. Okay, so similarly, for your buildings also, there is a scheme. So this is the scheme name as Griha. So Griha is an independent platform founded by the Energy and Resources Institute TERI under the Development of Solar Cities program. Nowadays, government is also making that okay, smart cities and solar cities also. So in that scheme, basically, this is a concept of making the energy efficient building. Means it is not like that your college, your institute, or your building. Means every building, it may be institute, it may be hospital, it may be any educational institute or factory. Any building can be make energy efficient. However, we have to follow a routine, a normal procedure. That procedure is basically based on that how much light is coming into your premises, how much what is the procedure, or what for the waste management. And see, there are so many criteria which we have to full. This is like similar to the NBA process. Means as in the case of NBA also, we are getting different ranking, and we have to fill the form. So this is similar to that. So MNRE had procured few cities for development as green city. In the city, solar traffic signals, solar LED lights, solar blinkers, power packs, and other systems used by the community on daily basis will be implemented by this agency. Further, again, there is one very good shops are also being established to provide product. Because if I want to purchase a like solar charger. So definitely there should be some specific shops also that will provide me the product which are running by the solar or by this type of renewable energy source. So under the Akshaya Urja program, there are small shops are being established in every district by the government. This program is supported and again monitoring by the state nodal agency, again central funded agency in terms of some loans, soft loans. I think it is like a startup also. So means government is also giving you subsidy. You can get the loans in Mudra Yojana also. There are so many yojanas are coming nowadays to promote your startup. So let me see about some lines regarding the Griha. Ashish, again, kindly tell me, I am playing this video. So if video and voice is coming or not.
We humans, in order to make our buildings aesthetically pleasing, are paying less attention to the building surroundings. We are destroying native vegetation to
It is
create
coming?
more buildings and pathways, which is resulting in environmental degradation. We do not lay emphasis on the building's layout for proper solar
Ashish,
orientation.
voice is coming, video is
We
coming.
often disregard the
Yes, sir.
location,
Yes, sir.
size, shading of windows, and ventilation of the building, which leads to excessive heating inside the building. To reduce glare from unshaded windows, we draw blinds and turn on artificial lighting. Further, mechanical cooling is done to combat building heat, thereby increasing the demand of energy. In addition to this, mismanagement of resources makes our practice unsustainable. So, what can we do? The immediate need of the hour is to design buildings that are environmentally sound and resource efficient and stay the same throughout their lifespan. We call such buildings green buildings. Now let us have a look at the green buildings and their benefits as opposed to the conventional ones. Green buildings take into consideration the existing features of the site, thereby least affecting the nature. They are developed taking into consideration the building layout for adequate solar orientation and proper ventilation, thereby reducing the building's heat intake and maximizing the glare-free daylighting. Green buildings use efficient fixtures to reduce water wastage and also treat and use the wastewater generated on the site. They are particular about waste management and its safe disposal. They cater to the safety and well-being of human beings during their construction as well as post-construction. So how is a green building's performance measured? Green building rating systems have been designed to assess the performance of a building throughout its entire lifespan, ranging from inception to operations. The rating given to a building is directly proportional to its performance. So do we have a national rating system for India? GRIHA, Green Rating for Integrated Habitat Assessment, adopted by Ministry of New and Renewable Energy, developed by TERI, works on the principle of what gets measured gets managed. GRIHA assesses the performance of buildings against certain nationally acceptable benchmarks and rates them under 3 categories: simple, versatile, affordable GRIHA, GRIHA, GRIHA for large development. Based on the post-occupancy performance data of GRIHA-rated projects, it is estimated that 20 million square meters of GRIHA 5-star certified projects can save enough electricity to power about 200,000 urban homes and enough water to meet needs of 22,000 urban homes. So let's make green buildings GRIHA way. For more information, follow us on www.grihaindia.org, an initiative by GRIHA Council.
Okay, so I think you will like this video and also the content of this GRIHA. So this scheme again you can go you can implement it also in your institute or in your premises also. Even this is not specifically for any institute or any building. You can even implement your house also, but definitely there are some assessment. Let's see the assessment. This is the GRIHA for existing day scholar. However, this scheme is not normally used in India because we don't have the schools like this. So these are the different sections. So energy management is having 12 points approximately. Occupant health and comfort is having 8 point. Air quality, normally we are not having this criteria in our schools. Water management, solid waste management, and some bonus point. So what is the per capita CO2 emission, operation and maintenance? So there are different criteria. I think if you have undergone to some NBA accreditation process, so already I think you are seeing the similar type of processes there. Rainwater harvesting, waste generation, recycling, health and hygiene, social initiative. So like this some points are there, and based on that you can get the rating. Then this is the rating process. So online registration, first you have to do the project proponent can initiate the registration process. See, I think you already have the idea of RERA also. This is again a regulatory authority agency, basically for the basically flat for the buildings which are now running. So like this is one of the scheme. So filling the expression of interest EOI from available on GRIHA website. The registration is complete after the feasibility. This is same process. On successful payment of the required fee, the project get registered for GRIHA for existing. This is day school. It may be a building. It may be any hospital, any other building. Then orientation workshop, definitely the registration is followed by orientation work conducted by GRIHA Council, which intend to provide detailed information of rating. They will first explain you that, okay, these are the rating, these are the criteria which you have to address to the project team. Then they will collection of the building data and filling the survey form. So eco team under the guidance of teachers will collect. See, this is one example for the school. So wherever you are writing, wherever you are seeing the school or the teacher, so that can be basically generalized for another building also. Will collect the various building related data and use of the survey. Then to analyze the school environmental performance. Then the interim site visit. So the project team can choose for intern site visit to be conducted by GRIHA Council officially by paying additional charges. This will definitely help the team to collect the data for clarify any specific doubt. If any doubt is not there, so they can collect it by online or they can go for the offline visit also. Then the document submission, then the final site visit, submission of document, and then the final review, and then final rating will be awarded based on the document submitted and the observation mark. Based on that, this is the criteria. So different rating stars are there for different percentile. So if you have 46 and above, you will get the 5-star, or like this you have the various rating of that. So this is one of these schemes. So I think you like this scheme. Okay. Then some initiating launched by the government of India. So this is the initiating. So different, as I already told you that the amendment in national tariff policy was made in January 11 to direct solar specific renewable obligation. Means this is the obligation, means you have to purchase. It is not like that, okay, presently I am no use of the, I have no demand, so I will not purchase the electricity. It is not like that. You have to follow the RPO. Means this much of demand, this much of energy you have to purchase every time from the market, like this. And there are different central electricity regulatory commission, state regulatory commission. They have issued diversified RPOs, their framework, their tariff policies. See, tariff is also a I think a debit this means you can always have a lecture on the tariff policies also, because on the national level it may vary, from state to state level it may vary, from solar to wind to coal to nuclear it may vary. So I think many of researchers are working on the market, on the policy, on this type of tariff policies basically. And then grid connectivity of renewable source and their forecasting. Similarly, feed-in tariff, this is the basically kind of payment. This is a kind of payment in favor of the owner who is generating electricity throughout the new renewable sources such as biomass, wind, solar, and further feeding back to the grid. Means who is generating it, and then again it is sending to the grid. Owner, see again what will be the tariff, what will be the unit price, that will be decided by the state regulatory commission, central regulatory commission. Means there will be always a team will be followed, based on that they can follow it. Then again some REC, they have to purchase the REC also. Means if you are getting some electricity, so from the solar, so okay, this much of REC certificate. So if it means later also by using this REC you can further sell that energy to the customer or to another states also. In types of metering, there are two types of metering, so gross metering and the net metering. So again, gross meter is a unidirectional meter, I think normally we are using, and net metering is a bidirectional meter. Means if you are generating the electricity, so once you use it, and whatever the surplus power of there, so you can feed this power, feed back to the grid based on the data billing arrangement is made. So this is the basic difference in the net metering and the gross metering. Normally the grid tied solar photovoltaic rooftop systems are normally with having the net metering. Okay, so the states of Rajasthan, this is one slide related to the state of Rajasthan has also made a remarkable process of installing various energy projects. The state approximately 18 gigawatt. This maybe as on I think it is increased now by the 30% share, and by 20. Beside this, they have the solar potential of approximately 152. This is the solar potential. This is the solar potential. However, this is the installed, and the MNRE has target of approximately 572 megawatt of target by 2022. However, they have normally they have established it, because day by day different phases are commissioning, and they are working on this. So in Rajasthan also, Rajasthan Solar Energy Policy 14, and then amendment is there in 18. So they are also changing with this. So these are related to the policies. Okay. So now in both of the system, in let in the solar, so the classification based on that a single stage and the double stage. Means you can see the difference here. So here you can see that this is my AC grid and this is my load. So this is my load. So whatever the energy is generating here, solar energy, so this is the DC link you are seeing, means because it is the DC energy is generating from this link. So this is the inverter. So inverter is the power electronics converter, which will change this DC power to AC power. So here we can see that this is a single stage conversion. Means this is DC and this is AC. So we are converting this DC to AC. But here, if you will think that first the rest parameter are same, only the changes this DC to DC converter, which is a dash line. Means first whatever the DC is generating, we are controlling this DC, we are controlling this DC here, and then we are by DC converter, then we are feeding this DC energy to this to the capacitor, and then it is converted by using the inverter to the DC, from the DC to AC. This is a two-stage conversion. Now you can discuss definitely that, sir, what is the difference? The difference is that Difference is that in this case, due to the variable weather condition, due to the variable irradiance, this DC to DC converter can increase or decrease the output voltage. It can maintain the constant DC link, and also they can maintain the constant AC output voltage. However, here everything has to be done by this inverter. Means control algorithm will become complex here. However, the cost, if you will compare the cost, so definitely the cost of this scheme in single stage is less as compared to two stage. So this is the just conversion. So here we can see that, okay, single stage and two stage. So here the only one converter is there. Here two converter. Efficiency is higher, is lower because number of stages are there. So definitely it will affect the efficiency. And complex and simpler, there one controller is required. Here two controller. Compact, either bigger, lower. This is a general classification between these two. So it can be further used in Windows. So it means there also you can think about a single stage or two stage conversion depending upon the requirement. This is a research point of view. Okay, so this is a grid connected solar photovoltaic system. So the energy is supplied in the form of DC power from PV array and converted to AC power through the DC to AC converter, which is basically inverter. So the participant who belongs to the electrical side, so I can give you the suggestion that they can work on the inverter side, they can work on the DC to DC converter side, and they can run their algorithm into different atmospheric condition. They can run their algorithm under varying load condition like this. So presently, a wide variety of applications are running with a PV system. This PV system not only supplying active power requirement. This is very important, that whatever your PV system is there, that is not only supplying active power requirement to the local load, but also injecting the surplus power to the existing or the nearby grid by grid integration through this converter. Power quality is another one of the major tasks, one other major term which may be related, because see, many converters are playing as a role of conversion in these grid tied systems. So it may be renewable, solar or wind or another system. Then these converters affect the supply current. So that if your supply current is affected, means if it is becoming other than sinusoidal, it means that it is not sinusoidal, then it comes as a power quality problem. So power quality of medium and low voltage power network is becoming a major area of concern with the increasing of PV and other even wind also. The other energy penetration to the grid via power electronic converter. So power electronic converter is a main problem which gives basically problem to your system. So also the non-linear loads are also there which are used in the domestic and the industry purpose. So various custom power devices like active power filter, distributed static compensator, D-statecom, dynamic voltage resistor, and unified power quality conditioner. These are the interfacing at the PCC side between the grid and the load to overcome the voltage current disturbances and to improve the power quality problem. So therefore these grid connected systems, maybe a PV or maybe wind, they should not supply active power to the system, but also they improve the power quality. So the researchers who are working in the area of the grid tied connected systems, they can work with the same converter. They can work as a feeding of the active power, and they can also work with the power quality improvement with the same converter, and they can work like this as a multifunctional inverter. Okay, so this is some literature of this grid connected inverter. Okay, I'm not going into that because other participants are also there. So this is basically simpler, the same active power line conditioner, shunt active power filter, and other you can also use. All are connected in series or in parallel with the system. And definitely there are some algorithms also which we have to follow, like MPPT. So need of the MPPT is this is not only used in solar. This is a scheme, this is the algorithm which you can use not only in solar. This is basically means you have to extract the maximum power from the source. This is the basic thing. So maximum power can be extracted from wind, maximum power can be extracted from solar or any other source. Like it depends. Basically, there is a theorem also in your AC circuit, AC network. So based on that, this basically works. So there are P and O and neurophagy and other algorithms are there. Jaya and many other algorithms are there. B algorithms, which are basically used in this maximum power point tracking algorithm. So, okay, yeah, I'm not going into this. Yeah, this is the general scheme. So already I think we discussed. So this is the source, this is the inverter. So when this may be useful for the implementation point of view, who are working in the research point, work in the electrical side. So they have to work like this, means solar photovoltaic system, then some DC converter, then some inverter is there. This 3-phase 4-leg inverter is chosen because due to the distribution purpose, we are working on the distribution purpose like this. And then your controller is also there, which will basically generate the pulses for this VSC, means voltage source converter, and that can be generated the firing pulse for this inverter system. Okay, so this is some control algorithm. Okay, I'm not going to that. Oh, this is the difference. Yeah, this is the slide of that single stage and the 2-stage conversion. Power efficiency is approximately same. However, the THD is same, but you can go with the benefit that okay, the cost is case of single stage is less as compared to the 2-stage. So okay, thank you for your patience. And the conclusion I want to give that the renewable energy is basically on demand right now. Means the present trend is towards the renewable energy. There are different sources are there, and different control schemes are there. You can as a means subject expert or as a guide, you can do different you can do work different on different control algorithms. You can do work on the different topologies. So there are basically policies also, like the Deen Dayal Upadhyay Yojana, the Vidyutikaran Yojana, Kusum Yojana, Griha, and many other yojanas are also we discussed in this presentation. So okay, this is my conclusion. This is the future research area. So you can go always, as I told, in the converter topology, inverter topology. You can also have the reduction in the number of the switches. However, I will share this slide. No problem. Kindly have a patience. I will share the slide. No problem. Multi-level inverter, switching harmonics, optimization of algorithm, AI techniques, and distributed generation, and definitely the discuss of this time demand, basically integration of RES and control techniques. So this is for all from my side. Thank you for your patience listening. I hope that 3 videos you liked, and yeah. Thank you, Ashish.
Yes, sir. Thank you, sir. Participants, if have any kind of query, then they can ask. Okay. Okay. Thank you, sir. Thank you very much for the session.
Thank you, Ashish. Thank you.
Thank you, Nitin sir. Thanks a
Thank
lot
you,
for sharing such a valuable presentation.
Thank you, sir. Thank you. Thank you.
Participants, we are having another session at 12 p.m.
All participants, just pay attention for 1 minute. Link is given in chat box, in message box. Please fill up the link. Yes. Thank you.